anything concerning power, anything concerning electricity, anything concerning solar, it is here in this channel, The Physics Mindset. Today we are going to look at, as we have seen, the solar system, the panels. We are still on panels. As I've told you, we are ending the panel section. Then we go to another section of a solar regulator or a solar charge controller. Today, as we have seen the parallel connection, we saw how you connect in series. We saw how you connect in parallel. And some technicians will ask themselves, as we say, this channel is more of explaining, though the explanation will more be in practical way. If you listen well, you'll see it in practical way. That's what our aim is, to bring up the practical technicians and the engineers. Today we are going to look at the comparison between the series connection and the parallel connection. Okay? Let's see this. Let's say series versus parallel solar connection. Solar connections. I can put this. Okay. As we saw the last video, we talked about the series connection, and we saw how you connect the series connection, where you connect a negative, positive, negative, positive there in series connection. And we end up another video, then we're going to the parallel connection, where you will connect positive on positive, negative on negative. Okay, that is parallel. Then we said in series connection, our aim is to increase the voltage. Okay, if you have a system, after calculating your system, you calculate your inverter, you calculate your regulator using the loads which you'll use in the household. Okay, then you come up with a solar panel. Okay, and we have started from the solar panel. This is the solar, how a solar moves. You can't start from the load. You must first learn where the power comes from, where the generation is of the power is from the sun, the God-given free sun. It generates power for us. Then we went on the cells. Then we went on the manufacturing of the panel, the type of the funnel, the monocrystalline, the polycrystalline, the amorphous. We looked at those. Then we went on to see how a panel works, how it converts sun into electricity by the use of the other effect. It's called photovoltaic effect. Then from there, we saw that panels on roof must be connected when they are more of two and more, any number. Okay, they need to be connected. Which connection? That is the series connection and parallel connection. As we shall see, also there is a series and parallel. Then we looked at the series connection. After looking at the series connection, we saw that if we wire solar panels in series connections, our aim is to increase the voltages. If our system is working on the 12 volts or 20 volts, let's say 12 volts, if we add panels, we shall have, if our panels or our system is going to work on 24 volts, we need to, and our panel is of 12 volts. It means we shall add 2 panels in series to get 24 volts. Isn't it? Yes. Now, after there, we went on and found that in a series, we are aiming to increase the voltages. Technicians and solar technicians got to know this. In series, we are aiming at getting the voltages. For example, if we are using a 100 watt, when it's going to charge your 12 volt battery or 24 volt battery, your 100 watt, remember wattage. Remember how we said in wattage is power. We say power equals IV. This is the wattage, the power. Then current times the volts. Because these two things, they move together. The current, which is measured in amps, is the flow of electrons. Yes, the flow of electrons. Like this is your cable. You want to connect power or electricity. Okay, let's say this is our electricity. Here you will find the volts. Okay, let's say our volts is 240 volts. This is our electricity. This is our cable. This is 240 volts. In this cable, you will find a voltage and you will find current. That's why in a cable, the voltage is the one which pushes the current to flow. The voltage is the pressure which pushes current to flow. Okay? And current is the rate at which electrons move. If you have a small cable, small current will flow. If you have a big cable, big current will flow. Okay? This is a bit a sample of voltage and current. We shall look at that in more details. Now, our aim is, as we saw the series, that our aim is the voltages. Now we are seeing parallel. Our aim was, we aim at increasing the currents. Okay? Here in series we have, voltage. Voltages. In parallel, we aim at increasing the current. Here in volts, here in amps. Okay? Our aim here in series voltage, and our aim in parallel is current. We have a power which is in watts. Let's say we have our 100 watt panel. This 100 watt panel, it has the voltage, it has also the current. Okay? Now, we are going to see the difference between a series connection and a parallel connection when you're mounting your panels on the roof. Okay? This is your roof. This is your house. These are your solar panels. Okay? Now, we want to see each solar panel is 100 watt. Each solar panel is 100 watt. 100 watt means there is a voltage, it will produce a voltage of 20 volts and an ampere's current of 5 amps. Now, here comes to our question. Series versus parallel. Which is best to connect when you're on your house, a roof? This goes to a technician before you install a solar solution, a solar system. No, there is a solar, or every solar panels. It has a technical information behind it, where you will have to check and see the open circuit voltages, the current, the wattage, the voltage at peak, everything, all the information is behind. There is a sticker. Now, is it good to connect our panels in series, or is it good to connect our panels in parallel? Which is good? Which is good for us? I'm here to see the difference. Should we connect our panels in series to get voltages, or should we connect our panels in parallel to get currents? Which is good for us? Let's check. Which is better, to connect your solar panels in parallel or to connect your solar panels in series? Two options for technicians and everyone. Before you connect, all electricians, before you connect, please know this. Do the calculations. Do the calculations. Don't forget to move with your small bag. Hold your book. I call it a engineer's book or a notebook. Have a pen. Do not go for a survey without a book, without a pen, without a calculator. Okay? If you have a phone, there is a calculator on the phone. Okay? Like this, there is a calculator on the phone. Just put your phone in the pocket. That will be, it possesses a calculator on it. And go with a book for putting your data, recording your data, that the panel, the regulator, the inverter, because a lot of technicians, they just estimate, and which is not really good when you're installing a solar system. A solar system is not good. You estimate everything. You'll mess up with everything, and the client will call you. The client will call you, which is not good for a repetition for your work as a technician or electrician. Always calculate. Always move with the book for a survey. After surveying, ask the client what loads or what appliances are you going to use on the solar system before you do anything, before you talk about the prices. What are the goods the customer is going to put? Know the total watts. After knowing the total watts will give you the panels you will need, or it will give you the inverter sizing you will want, as we shall go. We are soon going there, how to size an inverter. It will give you which regulator, where we are going, which charge regulator or charge controller will need for this system to stand and work in good performance. Without asking, it will be not professional. Ask, because a customer, he will tell you that I need a 100 watt panel. Then you come and install. After you go away, you leave the customer's premises with the customer. Now the customer will get a coil, a cooking coil. A cooking coil has a wattage of 1000 to 1000 to 1500 there. 1000 watts to 1500 watts. You see how many 100 watts of panel goes into 1000. This is 100 watt of panel. How many do we need to go into 1000 to 1500 watts? This is a coil and this is panel. How many panels do we need to make 1500 watts? Those are too much, Too much. And the customer just gave you, I need a 100 watt panel. That's why I advise you, go with a book, do the technical survey, tell the customer exactly what must be done after doing your calculation. Calculate the load, calculate the distance, know the cables, know if the customer is going to put security lights, if there are 2 behind and in front, and the security gates, those security lights, let's say they are 10. Calculate if he has a TV. Calculate a TV, the wattage. I think there's it may be 75 watts, the flat screen TV. Calculate it down. Calculate the hours which the TV is going to work. Calculate the TV, that is where we shall go, ampere hours. That is now sizing for the battery. When you have your TV, it is 75 watts. Then you are going to watch it for how many hours? Okay, let's say you will watch a TV in 1 hour or in 2 hours a day. All this information, as a technician, you need to have it. A solar technician, never to do without any information with a book. Always record information. Record how many lights are in the house. Okay, sitting room, bedroom, corridor, kitchen. Those are lights. Then record how many amps, how many watts each bulb is going to be having, and how many hours each bulb is going to light. All this information, you need it before you start talking about the panels. Without those loads, you cannot get the panel. That's how I have sold you. The customer will tell you he needs a 100 watt, yet he's going to put a coil of 1000 watts or 1500 watts. Your system will blow. No, it will not even blow. The fuse will blow, the transformer will burn up, all the secondary or the primary coils will burn up, the circuit board of the inverter will burn out. Yet an inverter is expensive. Now the customer will say, even the battery will not even work for an hour or 30 minutes. The inverter will blow. Boom. The fuse will trip off all circuit breakers. And then a client or a customer will say, this technician doesn't know what to do. If you don't ask, which appliances are you going to put on this solar system? Okay, I was giving you a bit of advice before you go for an inspection or an installation of solar system. Let's go back. Let's go back to our point. Our point here is it good to install solar panels on the roof in series or in parallel? What should we do? As a technician, you need to do a series or a parallel. Which is best? Which is best in these two? We want to see our panels. Each panel has 20 volts, 5 amps, and 100 watts. Okay? Now, let us calculate which is good. That's why I told you Without calculations, you can't do any solar installations. Never. Though you are good in estimations, you will estimate and you'll not be perfect. You will estimate and not be perfect. Let's check. If we have our 3 panels, each panel has 20 volts, 5 amps, which is the 100 panel, 100 watt panel. We want to connect them so that we light our systems in the house. Should we connect these solar panels in series, or should we connect these solar panels in parallel? Okay. All our aim, if they are 3, which is having more power, we want more power. We want these panels to produce more power for us. Now, check. Should we connect in series connection? Will we have more power? Because they are the same. Should we connect in parallel? Would we have more power to light our system, the TVs, the lights at home? Which connection is good when the panels are the same? Okay, let's check which connection is good. Other technician will say, I connect in series. Others will say, me, I will connect in parallel. Now, who is good? Who is better? The one who has connected in series or the one who has connected in parallel? Who is good and who is better? Let's check. A simple mathematics. We have said our panel has a 20 volts, 5 amps, 100 watts. Okay? We say there are 3 panels. 3 panels. Okay? These are our panels. 1 panel, 2 panel, 3 panels. Each panel is 100 watts. Each panel is 100 watts. Now, let's say someone who has connected them in series. Check this. Now let us calculate in series. Let's start with series connection. Who is good? Series or parallel? If you have a comment down there, you can comment. Series, parallel. We have the same panels, 100 watts. I'm going to connect them in series first. Let's do the calculation. In series, we said we add on the voltages and current remain constant. Okay? This panel has 20 volts, 5 amps. This panel has 20 volts, 5 amps. And this panel has 20 volts, 5 amps. Which 20 times 5, you make 100 watts. Now each panel is 100 watt, which is okay. Now, let us do it in series connection. We see how many power do we have power when we connect in series. In series connection, we said we add on the voltages and our current will remain 5. Let's say 20 volts, 20 volts, 20 plus 20 plus 20. These are volts. Okay? Times. Our current will remain constant, which is 5. We shall not add this 5. No. We shall add this. The current is constant. The voltages changes or voltages increases in series and the current remain constant or remain the same, which means current will remain 5. Okay? Now here, these are voltages. This is current. We are looking for power. Let me do it like this. Our power equals IV. This is the power, which is the wattage. Power equals current we have 5 times the voltage. Voltages we have 20, 20, 20, 20, 20, 20. The same voltages. Now the voltage will increase, which is 60. 60 volts. Now here power equals IV, current times voltages, we shall have 60. Then we have our power. This is 300 watts. Okay. Now my people, here we have 300 watts. These solar panels, if we connect them in series, we shall get a power wattage of 300 watts. Okay? We are going to use the same solar panels to calculate the parallel, and we see where do we get the more power to power our system. Here in series we have 300 watts. Now people who are going to say serial connection is good, I will need your comment down there. Let us calculate the parallel connection using the same figures, the same watts, the same voltages 20, the same current. Each panel, there are 3. Now let us connect them in series. Here we are saying in parallel, the voltages increases. Now in series, the voltages are going to remain, in parallel. In series, the voltages increases. In parallel, the voltages will remain constant, 20. Then the current will increase. Let us see. In parallel connection. Okay? In parallel we said we increase the current, whereby we said our current is 5. Each panel has 5. This one has 5. This one has 5. Let us add on our 5. 5 amps, 5 amps, 5 amps. This is panel 1, panel 2, panel 3. We shall have 15 amps. Okay? Now, multiply by the voltages. As we know our formula, our voltages, which is constant, 20, 20, 20, we take 20 to be constant. Now check the formula. Power, we are looking for power or wattage. This is power, which is measured in watts. We are looking the same panels, the same sizing. It is 100 watts, 3 panels, each has 12, 20 volts and 5 amps. Now we have connected in series, we have 300 watts. Now let us see if we connect them in parallel, how much do we get? Power equals IV, whereby I is the current and V is the voltage. This is the thing. Current times the voltage. Current we have 15 times the voltages. Okay? That's why I told you, if you never know times the voltages, you say 15 times 20, you get 300 watts. This is power. The same thing. We have got the same power. Now, the science is coming. The science is coming soon. In serial connection, we have got 300 watts. Okay? In parallel connection, we have got 300 watts. Do you see that if we have a panel which is the same sizing, the same size, they are the same 100 watts. Okay? Even though you connect in series, the system will work. Even though you connect in parallel, the system will work 300 watts. Even though you connect in parallel, in series, the system will work. We shall have the power, which is equals, both in series and parallel, they produce 300. I'll bring you the science now. If you have your solar panels, okay? If you have your solar panels, let me just rub this. If you have your solar panels, when they have different wattage. Now, the difference, we are coming another trick whereby technicians, they don't know, some of them, they don't know how to connect this, the series and parallel. We said if you are having the same panel, the same panels, 100 watts, 3 of them, or you have 4 of them, if you connect them in series or parallel, series, you have seen, you get the same power. In parallel, you have seen, you get the same power. Now, here comes a scenario when you have one panel, let's say this is the panel, this is the symbol of a panel, it has 20 volts, 5 amps, this is 100 watts, okay? Now you have another small panel is having 10 volts, 2 amps. This is 20 watts. Okay? You come a scenario when a customer has a panel, a big panel, and a small panel, a 20-watt panel and a 100 panel. Okay? Now, technicians, do we still need to connect series? Do we need to connect series, or we need to connect these panels in parallel? Should we connect them in parallel? Let us have to see. In parallel connection, when a customer has a 100 watt, a big panel, then he wants to join a 20-watt panel. What do we have? What do we supposed to do? Check. Let us do the calculation in series connection and we see which connection is better. You first do in series connection. In series connection, the voltages will add on, but current will remain constant. Which constant? We shall take the lowest current, which is 2. You don't take the biggest current, you take the lowest, which is 2. The voltages plus, let's do the power we want, which is having most power, which will produce much power. Is it series connection or parallel connection? In series connection, can we have more power to produce, to manage to light our system? In power, we say IV, current minus voltage, where current is 2. The lowest is 2, because as we said, electricity moves from high points to low points. Now, electricity will move from here to here. So we shall consider this, the lowest current. When you're doing your calculation, use the lowest current. Okay? Don't use the maximum current. Use the lowest current, which is 2. In bracket, the voltages will add on we have 20 volts and 10 volts and 10 volts, whereby we shall have 2 times, this is 30, okay? Our power, therefore our power will be 60 watts. Do you see when you're connecting series? Our power, when you connect this 100 watt with a 20 watt, you will reduce on the power of 100 watt by this 20. No, not by 20, here you come 80. The power will reduce. Some people will think when you connect in series, a 100 watt, some people, this is not this. When you connect a big panel with a 100 watt, with a small panel, any size, either 15 or 25, you have your 100, let's say you have your 150 watt, you have another 100 watt, and you connect them in series, the power will give you less. As we have said, 100 watt in series and a 20 watt in series, the power is 60. Okay? Now let us see if you connect the same thing in parallel. Okay? In parallels. Parallel connection. Parallel connection. Parallel connection. What happened? What happened if I connect these two panels in parallel? What happened? Should I get also 60? As we have seen, if these panels are equal, even though you connect them in series, you get the same answer. Even though you connect them in parallel, you get the same answer. Now, if I have a different watt panel I mean a 100 watt panel and a 20 watt panel. Any panel, any figure you feel like, or you may have a 200 watt panel and a 100 watt panel. Which connection is best? Is it good to connect in series or good to connect in parallel? And this in series we have got 60. Let us connect in parallel and we see. As we said, in parallel, current is added on and voltage remain constant. And which voltage should we take? The lowest voltage. Okay? Let's say power. We are looking for the power, which is the watts. Which watts is good for us in parallel or series? Which is IV. Current, we say this panel, the big one has 5 amps. The small one has 2 amps. Meaning we add on the currents. In parallel, currents increase. They add on 5 times plus 2 times, in bracket, times the voltage. The voltage, this big panel has 20, this small panel has 10 volts. Okay? Now, we use the 10 volts. Okay? Times 10. Our power will be this plus 5 plus 2, which is 7, times 10. Therefore, our power will be 70 watts. Have you seen? The same panel, this 20 volts, 5 amps, 100 watts. And a small panel of 10 volts, 2 amps, which is 20 watts. Meaning, this panel has 100 watts, this panel has 20 watts. If I connect them in series, I will have 60 watts. If I connect these panels in parallel, I will have 70 watts. We have not changed the figure. We have used the figure of this big with this small panel. The same thing you can do to calculate your system. If you can use the big panel, should we try to use the big panel? Now here it shows that to connect your solar system when they have different wattage, is best to connect them in parallel, where we are aiming to increase the currents. Okay? Now we have seen that a Parallel connection, when you have the same panel, it is okay to connect in series and parallel. When the panels are not of the same size, always use the panel width which is small. Use that panel which is small to calculate all your calculations, and you will see that parallel connection is better than a serial connection. Thank you for watching. See you in the next video. Bye bye.